So let's get right into it. We're looking at DAGKNIGHT, a consensus protocol that claims to have no limits.
But to really get what DAGKNIGHT does, you first have to understand the problem it's built to solve.
You see, most protocols have to plan for the absolute worst network conditions. It kind of holds them back. And that creates this huge trade-off. Security works, but only if the network behaves perfectly within those limits. This is where DAGKNIGHT comes in. It just gets rid of those hard-coded limits completely.
It's actually an evolution of the Phantom protocol, building on that block DAG architecture from COSPA.
So what does that mean? It's all about finding the right K cluster, which is just a group of connected blocks. So here's the big shift. Instead of a fixed K, DAGKNIGHT is always searching for the smallest K that'll work. And this is how it does it. It checks different K values, finds clusters, and picks the smallest one for a majority. Okay, so what does all this mean for the network's actual performance? Let's take a look.
Well, when the network is healthy and fast, it just flies. It uses a small K, and confirmations are quick.
But if things get congested, it automatically adjusts, using a bigger cook to keep everything secure.
The basic security assumption is still there. Honest miners in control, just without those rigid rules. So why is this a big deal? First off, the network's performance actually matches its real-time health. And second, this gets rid of those artificial constraints, so the network can really hit its full potential.
And maybe most importantly, security is just plain stronger. It adapts to reality instead of just hoping for it.
All right, let's just quickly pull it all together. Here are the key takeaways from what we've covered.
It really leaves you with a big question, right? What could we build if our networks truly adapted to reality?